Section 5.1, Exploring Probability. Sasha and Mike have to invent a fair game for a class project. And Sasha came up with this idea. Two people play. Each player has a container. Both players put 3 identical slips of paper, numbered 1, 2, and 3, in their own container. Each turn, they draw out a piece of paper. Player 1 scores if the product is less than the sum. Player 2 scores if the product of the numbers is greater than their sum, and neither if they're equal. 10 turns is a game. After each turn, they return all the slips. Is it fair? And this is how we define fair. And everyone has an idea of what fair is. In math, we say a game in which all the players are equally likely to win. For example, tossing a coin. So I know people like to say, well, fair isn't the same as equal. In math, it is. I'm not trying to tell you in the real world, but we're talking in the math world, which I mean is still real. Anyways, so let's see. Player 1 chooses and they get a 3. Player 2 chooses and they get their 3. The sum is 6. The product is 9. So player 2 gets a point. We see that right there. Let's play again. Okay, player 1 chooses. Get 2. This person gets 1. So the product is 2, the sum is 3, player 1 gets a point. A 1 and a 3, player 1 gets a point again. A 2 and a 1, again player 1. Well, is this feeling pretty fair? 2 and a 3, nope. 2 and a 3 was good for player 2. Player 1 gets a point. Player 1 gets a point. 3 and a 2, yes. Player 2, 3 and a 2, good. 2 and a 2, it's a draw, no points. Remember if they were the same. 3 and a 2, player 2 gets a point. Oh, I started over already. Anyways, you can see that player 1 seems to be getting a little more points than player 2 in general. Is playing it once a good way to decide? Well, no, because one of us might be luckier than the other. Mike says that you can use theoretical probability to determine if the game is fair. Do you agree? So theoretical is saying, okay, this is what should happen. This is theoretically what can happen. In theory, all the ways that player 1 can win, player 1 is if the product is less than the sum. All the ways that that can happen are if we have a 1 and a 2, or if we have a 2 and a 1, okay? But then if we get a 3 or a 2 and a 3 or a 2, oops, sorry, or a 2 and a 3, this is the case where player 2 wins. But what if we get a 1 and a 3, or a 3 and a 1? Player 1 wins. So these are all the ways player 1 can win, and these are all the ways player 2 can win. Remember, if we get these cases, nobody wins. Everybody loses. So theoretically, it seems like this is going to be more often. But when you actually go through an experiment, that's not always the case that's going to happen. More often this should happen, but that's not the way it works. Theoretically, none of us should win the lottery, right? The odds are awful, but someone does, okay? When you play Sasha game, I'd rather be player number 1 because that's who wins more. Okay, just to summarize, knowing the probability of an event is useful in making decisions. Experimental probability is given the probability of A is equal to the number A, the number of times that occurs, divided by and NT is the total number of trials in the experiment. So probability is how many times, probability of A is how many times A happens over the total amount. So what we were looking at is how many times does 1 win over the total ways to play. That's experimental. Theoretical says, okay, theoretically, what is the probability of A? The number of favorable outcomes, and this is the total in the sample space, where all outcomes are equal. So sample space is all the possibilities. So there is a way that theoretically all the possibilities is not what's going to actually happen when you play. There is a difference. Fair means all players are equally likely to win. An event is a collection of outcomes that satisfy a specific condition. For example, in throwing the standard die, the event throw an odd is a collection of the outcomes 1, 3, and 5. That's what it means to be an outcome. The probability of an event can range from 0, which means impossible, to 1, which is certain. You can express probability as a fraction, a decimal, or a percent. So this would be 0%, this would be 100%. You can't have a probability of more than 100. You can use theoretical probability to determine the likelihood that an event will happen, but theory and practice isn't always the same.